That's a long way away. Oh God. Just a minute, I'll try and get this a bit nearer. I'm messing about. I can't get the step ladders in here. I don't know if this is, this is not going to work. No, that's not going to work. Damn it. Ooh. Right. I'm just trying to improvise a bit. You have to forgive me. Let me get my. A bit dusty. Since all the workmen were here recently, I kind of inherited this thing. Yeah, it's covered in dust. I'm cleaning it because I don't want the dust to go all over the camera lens. Turn that around. Right, this should work. I don't want to drop my camera, my phone. Just a minute. Wires wrapped around there. What I'm doing, this is going to work. Oops, this is going to work pretty good, I think. Yeah, that's a lot better. Let's get this in the way. Right, so I'm leaving the charger plugged in so it won't get so hot, hopefully. Right, I'll just make sure my audio is working. Yeah, testing. Yeah, so I'm using my phone. Alright, so I wound the new small coils and I've actually tried them, and to be honest with you, useless. Useless. I kind of I half expected that. The reason is I put 100 turns of 30 SWG wire on each coil, and there wasn't really enough copper for the reactance to take place, and I actually got the current, believe it or not, the current down to virtually zero. It was so small, I couldn't even measure it on my meter. It basically said 0 milliamps. I thought, wow, you know, but the trouble was there wasn't enough flux to actuate my magnets in my concentrics. These things I made like 5 or 6 years ago, and all the different iterations and variations, and what were the C8s, and I mean I'll just review C8, C6. So all these different versions I've made, including the mini the mini C8s, the tiny little ones. Been working with these for years, like now. Oh shucks, everything's falling on the floor. Right, so it was just a question of getting the right orientation, combination, whatever. So what I decided to do, because the little coils don't work, was I adapted around these coils for this generator, this rotary system. And there's 700, well, there was actually 800 turns on one of these, and it was not matched. So what I've done is I've taken 100 turns of wire off. I think it was that one. No, it was the pink one. It was this one. I took 100 turns of wire off because it was 800 on that one, and now they're all 700 turns. So these are actually matched. They're all balanced. So I'm going to put these in, and we're going to see what happens with bigger coils. I've been making some improvements to my my corners, my lamination arrays, so that we can actually pop these coils in. Let's just move that part a bit. This one wants moving down a bit. Right, the elastic bands pull everything together. I haven't even orientated the polarity on these yet. I need to do that first. So what I'm going to do is I'm going to get my compass. Get my compass, and I'm going to get the right pole arrangement wired correctly. So I'll just get some ordinary batteries just to do this cell thing. I'm going to try and speed things up because I don't want to be live for too long. People get bored. So I'll swap this around. Let's make these two common. So I'm going to use a white jumper lead to common that one with that one. So these are in series, you see. Right, so these two are in common. Now I've got to connect my battery to get them polarized. It's a lot easier to do it like this than it is to start assembling it and having to swap wires around, and it just makes life a bit easier. Right, so let's connect that one to there. Oops. Right, I'm just going to touch my common wire, my jumper. I've got it wrapped underneath there now. Right, I'm just going to touch this to check the polarity on my compass. I don't know if you can see the compass. No, you probably can't. Right, so this is south on that one. Let's see which one. Let's move that away. Just want this one. Let's see which one this one is. Oh, these wires are quite thin and hard to see. Oh, that's correct. Actually, that's wide right. Let's just double check. Oh, it's too far away now. Yep, that's wide right. So these two wires want to be together. So I'm just going to tie these wires together. Oops, there's bits starting to fall off there already. Right, now I've got them commoned out. Take my compass out of the way. I might as well fit them onto the concentric so that we know where they are. I need another damn it, didn't I? Looks like I need another torch. I hope I've got enough torch. That's the point. Right, so let's see. Oh, I should have, because yeah, I have some toys on here, so we should be alright. Let's see, how many will go in there? How many are we short? Hang on. Hope not. Let me just measure. Just disconnect that. Stick it over here a minute. What's the depth? Oh, I should know that. It'd be 8mm probably. Yeah, because these toys are 8mm. How deep is that? Oh my god, that's 11.86. That's too big. I need 2 toroids. Shucks. Damn it! I'm going to need 2. I'm going to need an extra toroid on each one. Oh, I could take them out of there. That's the point. I'm running out. I'm going to have to take them out of my generator, my other rotary system. I can nick the toroids out of there. Running out of parts. I'll just take them out with concentrics without breaking them, hopefully. I don't want to break it. I've got a weight on it with a big pliers, so I'm just going to swap my pliers over on here. I don't want to. I'm going to use a hammer to hold that down, because it's just so the camera doesn't fall over, that's all. Right, that should work. Right. Getting these toroids out is a bit of a bugger. Right. Oh, there we go. How many do I need? I want 4. So I've got 2 there. Oh shit, I glued them together as well. So I'm starting to nick parts off my, actually, I don't know. I think I glued them all together. Oops. Actually, is that gonna be a problem? I'll have to see if I can split them. Anyway, I need to get these off this one as well. I'm just gonna. Yeah, my rotary generator, I'm not using it now, so I might as well take the parts off it. So, I mean, I'm not having much joy with it. Right, okay, I got them out. I've got enough toroids now. I just need to split these without doing any damage. I'll take my mini concentric 8s off there. I'm pushing it on the table because I don't want it to fly across the room. Right, stick that on the fire. Right, okay. Get these separated is going to be a bit of a problem. I foresee. Hope I can split it with my knife. I don't want to break the damn thing. Oh, there we go. I managed to split them. Yay! That wasn't so bad. I'll split the other 2 because they're super glued together, you see. Yeah, thank you. Sometimes you can't get them apart. You know, then you've got to soak them in acetone overnight, because if you try to twist them out, if you try to force them, you can break the ferrite. It's just too brittle. Just scraping the glue off. So there's a combination of materials used on my generator. It's the output coils, the welding rod. I'll take the core out actually to show you. That one's a bit stiff, I'll take the other one out. So when I made these cores, I used welding rod, which is 1.6mm thick welding rod. This whole block is packed with little welding rods in a 3D printed mesh of holes all the way around, and then I've got the middle cores, which are the ones that intersect. It locks everything together and it overlaps and everything. So yeah, that's for the output section. Put the core back in so I don't lose that. Just getting the super glue off. That's not so bad, that one. I've been up for more than 20 hours and I'm kind of tired, but I've been watching videos and I was thinking, oh, why don't I just do this tomorrow? And I'm thinking, yeah, why not? And then I thought, well, it's Sunday today. I've got to give people something to watch when it's boring. Everyone's locked down again in the UK. Well, it's not a bigger lockdown. It's not, the lockdown's not as bad as it was previously. People are starting to get fed up of it, and shops are starting to stretch a bit. And some shops are opening just in the mornings, and they're not permanently shut down. They're just minimising their hours, and which is a good thing because it enables the shops to survive, and we certainly don't want corporate Big Brother to destroy the little man, do we? We want the little guy to survive. The big corporate shops have got all this money. Right, so I need to put an extra one of these. These coils are a lot longer, and I'm pretty sure that these longer coils, now this is still 30 SWG wire. Same wire that I put on the small one, but the impedance of these large coils is about 16 ohms. Well, think about that, 16 ohms. Technically, I could drive this with an audio amplifier. Yeah, that's perfect. Yeah, that's exactly what I needed there, because you see, there's an overhang, and I should have about 2.5mm there. Let's see. Well, we've got 3.77. That's it's near enough. 3.77. That's good enough for the coupling, because that intersects with these things. Actually, no, that might be a good bit. Oh, it's going to be a good bit more than what? Yeah. Oh well, it's fine. I've actually got more on there. That's okay. I can move the coil about a bit. You see, these other two at the bottom are glued on as well. I glue them on so it just gives me something to anchor to. So I need to put another ferrite toroid in that end. Oh god, it's tight. Oh god, it's gone in anyway. Right, so it's a mixture, it's a bit of a hybrid. It's a mixture of ferrite and steel. So now I should be able to pop this into here. Let me just orient my wire so they stick out the back. Push that to the bottom. I'll hold that in place while oh god, I hope it's going to fit in here. Actually, it's going to be quite a bit longer than it usually is. It's going to come off the runners at the back because I've made these sliding runners. We're going. Oh no, it's not going to go in. I'm going to have to take my end stop are out. I put a nickel end stop in the bottom there, and that's constricting me a bit, so I'll have to pop that out. Now there were temporary things I put in. There we go. I have to think of it. I have to make a smaller end stop. It's just when I'm standing on its end, so that everything doesn't slide off the runner at one end. Right, I should be able to get this bigger coil assembly in now. Oops, the elastic band's pulling it together. I'll take the elastic bands off a minute actually. Right, let me just get these batteries out of the way so I don't accidentally short something out. I'll just slide that to the end of the runner. And that one to the end of the runner. It should go in there now. Oops, magnet stopped pulling on me. God, this is going to be close. This is. It's going to be a very tight fit. Oh, yeah, it's just going to work. That's why I made it adjustable, because I knew that I'd be trying different sized coils. And there we go. Bigger actuator coils. Now let's push this thing together. I was twisting a bit to go in. Going in there. Bit of a tight fit. That one's in better than this one, so there's something sticking somewhere. I think I know what it might be. Let me just take this top off a minute. I've got some glue somewhere. Something fouling up. Take this coil off a minute. Where's my knife gone? Oh, it's over here. Try not to mix the ends up, because it's got to be in the right way around. Why is it not going in? Oh, I see. I think I've got it. That core one's pushing in a bit. That was it. There we go. Perfect. Right, I think. Yeah, it wants to be. The coils want to be closest to the corners, really. Where the flux is shaped. The flux lines are actually shaped. You see, when the magnetism for the static magnets is actuated, the lines are not moving around. They kind of pop out. I don't know how to explain it. They're not vibrating like they do with an electrical signal. So you don't get power from it. If the lines aren't moving around, the flux lines aren't dancing around, you don't get power conversion from that, because the magnets are not moving, if you understand what I'm saying. You know, we talk about cutting through flux lines and all that. So what you do is you've got the batteries, I mean the magnets are like batteries. Think about the magnets as a reservoir of water in a tank, but the water's not moving, it's not doing any work. So the coil basically is like a pump, and it sucks that water and pushes it in a tight, constrained thing like a jet. That's the best analogy I can really use. And if you're on the other side, the wide aperture side, there's not much movement, so you're not going to get power from it. But on the compressed side, where the flux lines are compressed together by the coil, then you get power from it. That's basically a simple analogy way of explaining it. But because the concentrics, because they're like huge batteries of reservoir, most people seem to be trying to get energy from nothing. You can't get energy from nothing. You can't suck energy out of the ether, which is basically a vacuum. You can't get energy from a vacuum, because that's why it's called a vacuum. There's nothing in it. You have to have a reservoir of energy, and that's what a magnet is. It's a reservoir of energy. How you utilize that energy is the whole point. If you don't know how to utilize it, or if you utilize it wrong, it's not going to do a damn thing. As I found out, I found out I got a lot of current with it, but no voltage, and the coil shapes it so you get the voltage. Right, so that's in. Oh, it's a bit cockeyed on that end. I don't know why. Oh, I see. Right, I want my elastic bands on again to hold everything together. This is half of it. Right. So that's the bottom. That's one half. It's not very close to that corner on this end, but yeah, I'm just gonna hope for the best, and it might be the cores that won't move in a bit, but all I'll have to do for now. That's one half, so I can stick these on. Right, now I've got to do the other end, the top end now. Somewhat creaking. Right, it's coming off the runner again. Push it along a bit. Right, I need to put a stopper on this end again, but I took the other stopper off, you see. So that stopper that I had before, this thing is just a bit of scrap plastic I had. I have to chop that down so it doesn't roll off the end and not disassemble itself, like that movie Short Circuit. One of my favourite movies. No disassemble. I'm going to split this. Right. I'm glad I didn't use much acetone on that, otherwise it would have been really difficult to get this apart. So I'm going to stick this in with a bit of Yoo-hoo glue. It's less permanent, and it'll just hold that thing, this little thing, from falling out. I don't want it to be permanently in, because if I ever decide I want to take that out again, I can use my chisel. If it's bonding permanently with acetone, it'll never come out. Right, that's one done. Here's the other end. I've still got the small coils in there, so I've got to take this one apart now. Actually, let me move this back a bit out of the way. Put my capacitors over there, I think. Right, I'm going to take this one apart now. Right, I'll just twist that. Oh, I think I'm out. Oops, I'll have to put that back in. Oh, sort it out in a minute. Got you. There's the other coils. It didn't take long to. I just speed wound them, but I did them on my coil winder, so I know exactly how many turns on it. But they were, yeah, kind of crap. These are stuck together as well, but that's fine because two of them are stuck together. These are meant to be. Doesn't matter which way around I put this in because alternate poles anyway. I want to make sure they're seated in right. Right, so I've got to do the same thing with these coils now. One's a different colour, but it doesn't matter. I've got to get these polarised right as well. Obviously, wiring them, swapping the wiring around for the pole, the actual input, because they're in series parallel anyway. That won't be so bad. I just want to get these orientated right way around. Really, it's just I want to use the shortest wire. To the shortest wire. Yeah. So this is the shortest one. And bit of emery paper to take the burnt enamel off. Right, I'm just gonna see if the poles are wrong. I'll just turn the coil around, but I shouldn't need to do that. Ouch, that's sharp. Alright, where's my compass gone? Oh, there you are. It's just to get the poles right. I need my battery again. I don't know. I'll try and get it so you can see. I don't think you'll be able to see the compass. Well, we'll see. Oh, I've joined these together, but I used a jumper last time, but never mind, we'll find out. Right, which way is which? Right, so the needle pointing north over there. So if I connect this one to that one, it should still point north, if this is right. with this other coil, it should still point north. Yeah, it does. That's correct. Right. I can get rid of this battery now. So I've already tied these together. As long as I don't swap them around, I'm fine. Once I get this on, they won't shift. Won't work on its side, that's why I couldn't turn it towards you. Okay, so I'll just get this popped in. Oh, it's tight. Why is it not going in? Oh, I see why. These, the slightly stepped, they're not perfectly lined up. Damn it, I'm going to have to split them. They're not lined up properly. I hope I can split them. These are the ones I glued recently, so they're going to be a pain to get apart. Well, I'm going to have to go in the other room, stick them in my vise that's got rubber on it. Then I'm going to try twisting to get them apart because these are not lined up properly. I'll be back in a sec. Well, that's not working. That's not working. So I'm gonna get two more out of here. I'll just get the ones out the back. That's probably an easy way of doing it. Oh, I'll pull the whole coil out. I don't want the whole coil out. I'll go for a different one. Try one of these at the front. Ah. Ouch. The whole coil's coming out. Actually, I've got it. There we go. This one should split easier. The super glue's a bit older, you see, so it'll be more. Oh, it's probably a bit. Oh, it's not lined up properly either. I can feel a step. That's the problem. I'll try splitting it. I'm going to use my bigger knife. Got you. Thank you. Thank you. Thank you. Thank you. I love it when it pops apart. Because I don't want to be ordering more of these bloody things. They're too expensive. They've gone right up in price on eBay. I've got 100 like. I got not 100. I got 50 of these for about £5 or something. It was one of them. What do you call them? Lucky bags. And I've got on eBay now, and they're like one each for £1 something. Or is it £2 something? from China, obviously, and what with coronavirus, getting stuff from China, I think it's probably going to be extremely slow right now. Oh shit, look at that, it broke. Or maybe it was already broken. I think I glued it together. Oh no, I'm going to have to super glue the damn... You see, this is how... Oh yeah, it's been broken before. I'll super glue that together. Damn it. Oh. No worries, you can glue them together. I need my glove. Won't make any difference. I don't want to get glue all over my hand. You've got to meet up bang on. Right, there we go. Bit of acetone, where's that gone? Acetone on my cotton wool. Just to clean off the surplus. Yeah, it's stuck, I think. It's not falling apart anyway. I couldn't even see the seam on it before. Sometimes you can't when you get them stuck together, right? Alright, so that one's cleaned up. I can take my glove off now. So I need to stick these two together, but they've got to be lined up. Oh yeah, these have been bottomed before, because oops, I can see I've just checked the temperature of the phone. It's getting quite warm. Let me just make sure it's still working. Anyway, I can see it on the computer. I'm on the virtual machine again. Just getting the surplus glue from before off. This is the other one. Ferrite's pretty good for sharpening your knife on. When it's done right. Right. And clean that. Right, I'm going to have to stick this together. I need my glove again because it's got to be meeting up properly. So what I do is I hold it between 3 points. Finger there, and then that way you get it dead center. When you feel it with your fingers, you can get it dead center. So what I have to do now is put glue on here again. So it's got glue on, and then put it together, feel it with my fingers, make sure it's lined up right. So it'll be lined up bang on. Otherwise it won't go in the bobbin. Yeah, I think I've got it. I'm rotating it to feel it evenly all the way around. Put that down there a minute. Get this glue out of the way before I knock it over. And a bit more acetone. Just clean the outside up. Right, hopefully that'll fit in there now. I should have got it dead straight. If it's not dead lined up, it won't go in this bobbin. Oh, it's gone on. Yay. Is it all one piece? Yeah. Right, so that's worked. That had a precision as well, because bloody hell, that was a tight fit in that bobbin. Whew. I'm glad I don't have to split it again, I tell you. Don't be going through that again. So I've got this one ready to put together. So I want 2 extra ferrites. Oh, they're here. 2 extra ferrites. Put one in that end. One in that end. Now we can put the. I'll put this back in this thing later, because they were stuck together anyway. But, right, so this is ready to go onto this one. Oh, I've got to take that other thing out, and I'll just take that off a minute. My spacer. Oh, that's why I use weak glue. It's a lot easier to get them out. I'll just measure it by the other one so I can split it the same as that one. I think it was about there. Oops. Oh, damn it. Lost my place now. Oh, that other one's not even glued properly yet. Right, I'll stick this one down. Oh, I'll put this back in first. I can slide them on from that end, but it's a bit quicker if I put it in first. Alright, so put this in here. Right, end. Won't fall out because that stopper there. Oops. Oh, this is close. Oh, them want chopping down. I just realised the inner liners want trimming as well. Always some of these things want trimming. I'll put them in as an extra guide, but they'll be too long. Why is it not going in right? Oh, I think I know why. Oops. A minute. That bobbin wants to be pushed in a bit. That coil wants to be in a bit more. That's it. That's better. A bit more. I think that's about right. Now the other one. The other one's a bit out as well. Oh, that should be it. Right. That should be. Actually, that should go in a bit more, but I think I know why it's not. I need to trim a bit of this off. A little bit of countersink in. I think I know why. It's the bobbins themselves. Because of the older bobbins, the rim is a bit wider. But I'd rather trim it up here than up there because I might catch the wire. Ow! Nearly caught myself. Let's see if that works. I think it's going to be fine actually. The ferrite's coupled anyway. Yeah, I'm just going to leave it now. My head's starting to hurt. Is that flipping acetone probably? Yeah, the ferrites are touching, so it won't go in more. Now I can put this on top of it. Oh, elastic bands first. Where's my elastic bands on? Here they are. I think these are the ones. Oh no, these are the ones behind me. The reason is these are a bit longer. Oh, don't you hate it when these things snap and hit you in the face? Oh, damn it. Go back up there. Right. Right, that's on. Oh, I glued these corners onto these brackets because I got sick of them twisting on me and rotating, and it was really annoying me. Only that mild glue, so I can still split them if I want to. So now we put this bit on top of here like this. Oop. Something went moved. What was that? Back together again, look. With the bigger actuator coils. Be interesting to see what happens when I turn this thing on. I I hope my phone's not going to burn out. Let me just check the temperature of my phone. It's a lot better with this new battery, but I've left the charger in anyway, so it shouldn't burn out. I don't like this live streaming. Oh, let's check the temperature on it. According to this, my phone is 42 Celsius. That's not bad. It remembers it for a few seconds after I take it off. Right, so they're all connected. Now I'll turn this thing around. Oh, my wires are so twisted up. Oh. I want to test this now, but I'm so tired. Where did that come from? I can go in the bin. Let's see, what shall I do? Turn it over. Put it on its side. I'm getting my wires tangled up. I'm trying to work out the best way to turn this without... rotate that way. Yeah. Right, turn it around this way. Oops. Oh, I'm upside down now because my stoppers are on the other end. Shit. Forgot. Oh, you know what I've done? Oops. I know what I've done. I put stopper at one end and the stopper... Oh, damn it, I've got to take the whole thing off again. Hang on a minute. I've got the stoppers on the wrong end. Hang on a minute. Come out. Oh, it's come off anyway. Oh, it's come unglued. Oh, well, I don't even need to... Right, just put the damn thing back on again. Right, so all I've got to do is... this is driving me nuts. I'll just glue that stopper on the other end this time. Right, and it's at this end it wants to be, so it doesn't seem to have stuck last time. I don't know why. Maybe it wasn't in contact with the surface. Okay, right, now I should be able to turn this on this end. Right. I've just realised something. My transformers are so freaking big. Oh, they're so far near the end. I can't even stand this up on its end without the transformers resting on there now. So, yeah, I'm gonna have to just stand it up on properly. Oh. Right. Wires are getting all tangled up. I don't believe this. It's a nightmare. You know when you're using your multimeter, have you ever noticed? You always end up twisted all one way. It's because we're all right-handed or left-handed, and I think ambidextrous people. Is it the people that left-handed and right-handed, people can write with both hands, they probably don't have that problem, because sometimes they'll turn the wires clockwise, sometimes they'll turn the wires anti-clockwise. It'd be handy to be like that. I think my brother was like that, actually. My brother was left-handed, but he could write, I think he could write with his right hand as well. Oh, I miss him anyways. He passed away. Epilepsy, it kills you. It was really bad. Right, that wire can just stick that underneath. Alright. That's better. I'm getting my wire shaped in the right, organised now. So the only question is, do I have to retune this bugger? You know, don't get your hopes up, because 9 times out of 10 this thing's going to need a lot of tuning again. I mean, I might have to change these capacitors. These things that are soldered on, these brown bumblebee, whatever you want to call them, without the stripes, all of those probably need to be changed, but I'm hoping I won't need to change them. We'll have to see. I'm just trying to make sure everything's, pushed together right. So I've got to wire this lot up. So first thing to do, I've got my generator here, on my signal generator. H-bridge. The thing that people don't really understand about H-bridges is when you're sending a signal, it's AC, it creates AC from DC. But the thing is, with a H-bridge, one pole on the output of these two wires will always be ground. One pole, that might be ground for one cycle, the upper cycle. On the negative cycle, the other one will be ground. So when you actually connect this thing to something and you stick your oscilloscope ground lead to the output of this, what you're actually doing is on half the cycle you're shorting everything out, because yeah, that's why I can't put my scope lead on the output, because it's grounded. And if this is grounded somewhere else, then yeah, half the cycle is shorting out to ground. You see what I mean? That's the trouble with H-bridges, unless it's decoupled with, unless you're using a decoupling isolation transformer. That's the only other way you can do it. Right, let me think. These two middle ones, usually they're connected. They can be connected together. I'm glad I left the wires longer. So these two, where the two coils are in series with each other, these two actually can be tied together, because that's like a center tap. So a center tap on two separate series coils. These two in series, and where they join, you can actually twist them together with the other two coils, because that's a center tap point. So this becomes a virtual ground right in the middle. So, but the two wires that go to the start of the coil at the top, and the two wires that go to the start of the coil at the bottom, they could be crisscrossed. So that could be connected across to that one, and it might cancel it out. So that's what I've got to work out now. So what I do is I wire up just bottom half first, and I check my current meter, my readings, to see if we get any current. So what I'm going to do is I'm going to get the digital meter. Let's see, where can I put this? Actually, it'd be better if I move this forward a bit. Move that forward a bit. Get this. Is this lead? That's come off somewhere. That wants to be on here. Right, I'll stick my meter here, and we'll stick that on current. I'm going to turn this thing on in a minute and see what happens. I'm going to put these on. I'm going to take a guess, and I presume that I'm going to need a 1 microfarad metal film capacitor. I'm not sure. Let's just go with what I had on before. Actually, I made a mistake in the previous video. I said that these were two 730s, I think, in series, in parallel. Actually, they're not. They're two 330s in parallel. So the total was 700 nanofarad. So I actually made a mistake, a little error. But that happens sometimes, you know. You get a little bit confused. So I'm going to put these back on because these are in parallel with the input. And I'll have to do another video later, another live stream later when I'm holding the phone and moving it around, because I can't tune anything while I'm holding the phone very easily. So these capacitors are going to be parallel with the H-bridge output. First of all, I'm just going to connect, doesn't matter which way around these go because it's alternating. Actually, I'm just going to wrap that around there for now. That wire's probably going to fall off at some point. Knowing my luck, I need a bit of blue tack to hold this in place. It's loose. Right, and the other one is this one. These coils are the ones that used to be my generator, actually. So it might not work. We'll find out. This, I want a bit more enamel off this wire because it's... Ow! That's hot. It would help if I plug the leads in. I'll do that in a sec. There's nothing working yet anyway. On the black wire. Don't know if this is going to reach. Oh yeah, we're going to reach. Just lay that over the top. Milliamp. Common. I just need to turn the juice on across the room. I can't even reach it. I have to use a screwdriver. Got it. I'll set to 33 volts. Actually, I'll go up to, because these coils are a lot bigger, I'm going to go up to 40 volts on the input. But I want to find out what current we're going to... Oops. Why is it, when you hold the button down, it keeps overshooting. Right. Current. Right. I've got to turn this. Let's see if we get the light right on that. That helps. Okay, so now I need to plug this thing in, see what happens. Not a lot. Not a lot. We're drawing 100 milliamps. Something's not right. These coils are probably too weak. Which ones I'm connected to? Bottom. Oh, I see what I've done wrong. Oops. Oh no, I haven't. That's right. Oh, well. Can't hear anything. This is singing. Oh, hang on. We've got no voltage coming in. Just a minute. Hang on a minute. This capacitor is too big. Can't hear it singing very loudly. Oh, I haven't connected to the outputs. I haven't connected my outputs. Well, one of them is, but not the other one. I haven't got it all wired up yet. Jump to that one. We've only got half of this thing wired up at the moment, so it's not singing very loud. Why is that? I can hear the circuit oscillating, but there's nothing going through the coil. Hang on, the coil's can't be wired up. Hang on. It's not alright. Let's just disconnect that bridge again a minute. Shouldn't make any difference. No, it won't make any difference because the bottom coil set's not wired to anything yet, so that won't make any difference. Alright, I'm going to have to put some jumpers on that now, see what happens. I'm not seeing any output at all at the moment. Go across to this one. And that one to that top one of them's singing. Right. Okay. Right, one of them's singing, the other coil is not working, so there's a problem with the other coil. I can hear that singing, but the other one's not singing. Why? Yeah, there's definitely a problem, Houston. Right, so bloody hell! I'm just disconnecting that bottom one again. I need to test the. I'm just going to turn this thing off a minute. Right, turned it off because I want to check continuity of the those coils because I think I have a feeling I might have broken something. Put the meter on its side. Don't want to break my meter. I fixed the stand on my meter because I broke it before. I'm going to stick my meter there in front. Let's check the continuity. Yep, we're open circuit. When I touch the probes, well, which coil is open circuit? Which one is it? Is it the right one or the left one? Right, the left coil's fine. It's the right coil I've got a problem with. Shit. You know what, I'm going to have to end the stream and come back and do this tomorrow because it looks like I'm going to have to take this damn coil off and yeah. Unless this is broken in here. I'm just going to... Where's my knife? Put my knife down somewhere, I can't find it now. Where is it gone? It's around here somewhere. Oh, found it. I'm just going to scrape a bit of this enamel off here a minute. Oh, I'm doing it the hard way. That just, it might be a break here, I don't know. Not worried about a bit of bare wire. These wires are too long anyway. Right, let's check between there. Check between there and there. What? What the hell? Is it this end? I think it's the other end. It's this end. Oh, it's got to be this. Hang on a minute. I believe it. Ow! God, it's hot. I lost my blooming sandpaper again. It's somewhere around. Oh, I'll use this bit. Right, that should work now. Let's just get that wired up again. Kick myself if it was something so silly as that. Right, where's my capacitor wire? The white one. Right, let's check continuity again. What? What the hell? that's connected. On the other end. Ah, I figured it out. I figured it out. It's the join between that coil and that coil that's broken. So it's this one here that's the problem, right here, this join. Let's check that again. What? No, it's not. Just a minute. This one. That coil's fine. Where's my clips? Oh, it'd be so much easier with my clips on. Oh, it's bloody working now. Let's check between there and this end. Nope, it's not connected. What the hell? This is driving me nuts. Hang on a minute. I'm going to redo this. I'm going to cut this piece of wire off. I'm just going to redo this. I've lost my scissors now. I'm going to cut this join off right here. And I'm going to redo it. Start again. I'm going to burn my fingers again. There was obviously some enamel blocking the connection between those two wires. And this is going to sort it out. Right. I usually solder them, you see, but I'm just so tired. I figured I'd do it tomorrow. Right, we should be in business now. Right, clips between, actually I don't need the clips really now. I don't think. Let's just go between the H bridge, which is there and there. Yay, it works all the way through now. About bloody time. Right. Put me out of the way. I'm not really going to bother with that right now because I'm going to bed soon. I mean, I'll be up all night. Right, turn this thing on. That's better. I can hear the coils singing now. Now I need to connect the other coil. The top one. Sorry, the bottom one to the top one. Now, I am not seeing any current on here, so let's go down to milliamps. Am I on DC, yeah? I'm on DC. It's not tuned yet, so I need to get at least a reading so I can tune it. Where's my screwdriver? I'm just going to tune the frequency a bit. Very quiet. Oh, it's maximum voltage at. It's currently limited at 100 milliamps as well. I need to go up to 30 volts. Oh, I'm at 40 volts. Let's go down to. Oops. Ah, wrong one. Let's go down to 25 volt. Or 35. Current's gone right up. That's weird. Notice the voltage, I've just turned it down to 25 volts and the current's shot right up, which means I need to tune the frequency now. Until I get a reading on the meter, I can't connect the other coil up until I know if I'm connected it inversely or positively. Ah, I got a dip then. On the input current, I got a dip. That's what I'm looking for. Let's go to really low frequency. Nothing. Let's go to there. I'm expecting to get something. I've got a jump about here. Yeah. Yeah, this whole thing is tuning again. Put a bigger capacitor on here, let's see what happens. I'm bloody hungry. My current is just too high at the moment. I'll stick this, I'm going to hold it on a minute. Yeah, I think those bigger coils are too big. It's amazing what a difference it is when you. So I've been a 1 microfarad metal film capacitor. It's a bit too big. Let's just take one of these out. Ooh, look at sparks flying. It's 1 capacitor that. Let's try 2. Look at that. Fireworks. Uh, 160 milliamp, 40 volts will cause some sparks. Ah. I need to put my meter on AC. Oh. I'm going to put this meter on AC black one. Oh my god, my thing's getting quite hot. It's getting toasty. My MOSFET's getting toasty. Ah, I'm going to put this across a coil to see what... see if we're getting anything on the output side. But it's very small probably at the moment. That's what always happens when I'm trying to tune it. When you start off you end up with nothing. And you've got to spend... oh, come on, you stupid lead. Go on, stay on. Right, look at that. That's how bad it is. AC coming out, we've got 0.38 of a volt. There's no wonder it's not registering on there. Right, let's just tune this for voltage. I'll go to different, find another dip or peak. Oh, one there, 1.1 there, 1.5. 1.67. Right. Right, alright. Now I'll connect these leads up. I've got some AC there, so we'll see when I connect these leads up if it cancels it out or if it increases. These leads need to be connected to here. The H bridge. Oh, these slimy leads are annoying. And here, so is it going to cancel out? It's doubled, so that's correct. Wiring it that way, it's correct. So I've got all 4 coils are now wired up. They have to be connected, and now I've got 3.61 volts, and my current's dropped actually. Let's just peak this again. I think I need to increase my dead time. I'm just going to tweak this. Right, I've got my current to 60 milliamps on the high side right now, which is, I'm going to leave it there because my MOSFET should start cooling off because these, oh, that heatsink's pretty hot. It's because it was working and it's not with resonance. I'll show you what I mean. The heatsink is 40 Celsius. Oh, that one's 50. When it's like that, it's not actually doing anything. It's backfeeds into itself. Right. So right, I've got all 4 connected, and the tuning nightmare is something I don't want to be doing right now because I'm tired. But let's just piggyback. Where's my capacitors gone? 2, let's put 3 of these on. It can't go up or down. It went up. Did the output go up? 2.5. No, the output went down. That's what I expect with this thing. So when the current on the input goes up, the output goes down. So let's try, let's try the 1 microfarad. at this tuned frequency, the input went up to 90 milliamps on the high side. Took it off, went down to 60 milliamps on the high side. Let's take one of these capacitors out. Ah, 50 milliamps on the high side. What was that one? My voltage 3.21. Connect that one back up again. Ah, so I'm getting more voltage with lower capacitance now. Right, so I'll take that capacitor out. So I've got just one 330 nanofarad in here at the moment. And I'm at 40 milliamps on the input, but my output is pathetic right now. It's nowhere near what I had it last time, but these coils are so bloody big, they probably need more voltage, so I'm going to bump the voltage up. Let's go to voltage, let's go up to, see what happens if I go up to 40 volts again. Look at that, I just bumped the input voltage up to 38 volts on my output. Went down, let's bump the voltage down again. Right, I went to 35 volts on the input. Let's go down to 33. Went up to 30 on the input. I'm at 31 on the input, 31.03 now. 31 volts on the input now. And my current, oh my god, my current's dropped right down to, on the low side it's dropped down to 100 milliamps. And on the high side my current's dropped down to 20 milliamps. Let me just try and show you my phone. So 20 milliamps, but the current on the output is pathetic right now, because on the low side, look at that, the low side will, if you look, that's on current, we're about 110 milliamps right now. So this device, as I say, this generator thing of mine, it does some really weird stuff. I'm trying to get a torch back on my meters. It does unexpected things. When you think when your input current goes down, when you get tuned right, you actually end up with more output current. Because there's backfeeding going on. I'm going to tune the frequency again. I ain't got my oscilloscope on, so I can't tell you what frequency I'm at. Right, and my input voltage at the moment is 31 volts. There. We're at 31 right now. So I'm going to bump that down. Let's go down to 30 volts. I'm at 30 volts now, and my input current's dropped even more. I think we're actually using about 40 milliamps to drive it on the low side, and the current on that high side is 20 milliamps right now. 20 milliamps, look, on the high side. And the, oops, shit, what did I just click? I'm knocking my mouse by accident. I don't want to do that, I might kill my stream. And we're at 30 volts. Well, it's just 29.98, but I set it at 30. That's 30. It just seems it's current limiting. Oh, no, it's not current limiting. 20 milliamps on the high side. But we're not seeing any current in the output yet, because these coils that I put in, which I thought I'd try out, are not tuned. But let's let's go down voltage a bit more. I can't keep picking my phone up, I'm getting dizzy. Right, I'm going to go down to 28.6, 27.5. Oh my God, the current on the input is completely vanished. I'm not kidding you. On the high side, the current is nil. And on the low side, remember you remember I showed you in the previous video this box, this unit here, when it's turned off, it uses 50 milliamps. Right, I'm going to turn it off a minute. So I'm going to unplug the driver. Right, I've turned it off. This is the low side current right now. Oh, right, with it off. Right, I'm going to turn it on. Right, I've turned it on. With it on. Oh! With it on, the low side current, that's what it is right now. That's the low side, remember, 16 volts. Before it stepped up. This weird stuff, this is. And at the moment, my high side is showing no current. It's probably a few microamps or something. Or probably half a milliamp or something that's not registering on there, but anyway, but we're still pushing. Let's short the output out. Well, I've got a resistor here, but the voltage is so low anyway. I've got a 1.2 ohm. A 1.2 ohm resistor. I think it is 1.2. Brown, red, gold. Anyway, I'm just going to put that across the output. The current should disappear. See what happens. It hasn't really changed. .16, took it off. It's not changed. It's not connected right. I'll stick it across this capacitor, same thing. Huh. Oh, it did drop by 0.1 of a volt. But I'm still seeing nothing on the input. No current on the input of that saying. Actually, I can bridge these two back together again. I just remembered. Don't know if it'll make a difference. Shouldn't do. Have a look. Nope. Let's clip this meter onto a different output. Let's clip onto this capacitor over here. Right, that capacitor has got, there's no wonder there was nothing on there. Let's put that resistor across this other one, which had 3 volts on it. Let's short that one out. The resistor. Not really seeing a lot of difference. Yeah. Yeah, I need to get this thing tuned because it's not tuned, and these bigger coils probably aren't suited for this anyway. As I say, I thought I'd try them because I already had them from the generator, the other generator, and I thought, well, why not put them in? I had to take 100 turns off one to balance them out, and yeah, it's obviously not as good as the previous video where we had some great results. So we have taken a step back, but as they say, 1 step back, 2 steps forward. So yeah, hopefully the next step will be a step forward and not another step back. So it's all about just getting these coils right. But I've still got the original coils that were in there, were working really well. So what I was thinking about doing, these are the coils that I took out. And remember, these weren't perfectly balanced. They weren't perfectly balanced either. And these were wound with 28, is it? 28 SWG wire. I wound them, and they had a DC resistance of 2 ohms. That one had that was 28 and 2 ohms DC resistance. These two, and I can't remember what these are because I didn't even write it. Oh, that's 26 SWG as well. Yeah, they'll be about the same. Yeah, they'll all be 26 SWG. No, these are 28. These are 26. Sorry. Yeah, those two are 26. Those two are 28. That's what I was on about, being mismatched. So what I think I might do is probably wind some more coils. Say using 30 SWG. I'll wind more coils with 28 SWG, or I can just do some with 26. I don't know yet. I could wind 2 more coils to match these two, 26, right? And balance, have a 4 set all balanced to these, matched to these two. I could do that because these two are the same. Or I could wind 2 more coils to match these two. But I'm thinking these two probably are better, you know. Well, that's not today because I'm running up at the moment. But I'm just going to bump this voltage down a little bit. Oh, I can't go much lower actually. Because, yeah, I'll just try though. I'll go down to 25 volts. I'm on the wrong coil now, aren't I? We're going to be monitoring the other coil that I was on before. The other output coil. Right, we're back at that. Otherwise you won't know if we're going up or down. Right, I'm down to 25.7. Yeah, the voltage is dropping off. 20. I can't even see current on the input on the low side now. It's just disappeared. I'm at 25.0 right now, which is 25 volts on the input, and current still nothing. Let's just adjust the dead time on the oscillator. I'm not looking at, I haven't got the scope on. I'm still seeing no input current. Oh, we're going back up. Wow, we're going up to 3.35 volts now. I'm seeing a bit more current on the low side. I'm seeing 20 milliamps on the high side. Oh, that's weird. It's slowly climbing by itself. Oh, that's weird. The current on the low side is just slowly going up all by itself. I'm not even moving the damn screwdriver. Oh, look at that. We're almost at 3.6 volts again. Yeah, I need to increase that dead time because when I turn this voltage back up, it's going to go back into current limiting. Let's turn this dead time back up a bit. Oh, look at that. We went up to 3.6 then. Right, on the low side I'm at 100 milliamps, on the high side I'm at 20 milliamps. What happened then? I'm losing it again. So 20 milliamps on the low side. Yeah, these coils are not suited. There's too high impedance. Now, the other thing I could do is wire them in parallel instead of series, which would probably help. Oh, the top two are actually in parallel with the bottom two, but the top two are actually in series with each other, if you know what I mean. So the other way to solve this is to put them all in parallel, so that they're none of them in series. That's another thing I could do. That would probably bring the resonant frequency back into a region that might work anyway. But I think this live stream's been going on for too long now. Oh my god, 1 hour 52 minutes I've been going. Oh my god. Yeah, I think it's time to go, folks. I'm gonna. Oh, phone's getting hot. Yeah, so as I say, interesting. It was interesting and worthwhile trying these coils out because I already had them, so I only had to take 100 turns off one to balance them all out. I thought, why not try them? And I did, and as we can see, they're worse than the coils I had on there originally. So I need to go back to, and I did do some calculations earlier on those bobbins that were on there, that there's 18 turns per row on the bobbins, and there's about 6 rows. So work that out, how many turns there is on there. I think there's about 6 rows, maybe 7 or 8. Actually, I'm lost count. I couldn't remember exactly how many rows. I think there's 7 or 8 rows on there. But anyway, it's enough with 30 SWG, with 26 SWG wire. You could only get so much wire on there anyway. that's 18 turns per row. If it was 30 SWG, that is. So, oh god, yeah, I'm completely wiped out now. I can't even think straight. Yeah. All right. I'm gonna pack up. I'm gonna sort some decent coils out later because these obviously aren't working. At least I've got something to go back to which I know works.